All right, I think we're gonna try to get started. So welcome everybody. This is the talk about Google Data APIs. Yeah. Uh, my name is Johan, and I'm going to be doing this in English. I don't speak Italian, and so if you have questions, maybe we can find somebody later that can translate it for me, and I can do my best to answer them. So this talk is really about Google Data APIs and about mashing them up, so about combining data from different APIs into new applications, mashups, and things like that. And the focus is really to not only just show you how you would do this, but also to kind of inspire you. So I've added some example applications that we're going to look at just to kind of show you what's possible using some of these APIs. So I don't know if mashing up translates very well in Italian. So, to mash just means to combine. And, a mashup, for instance, some of the most famous mashups were, like housing maps where people combined, advertisements for apartments and Google Maps and things like that. We're going to look at some of this kind of stuff. A key ingredient in any good mashup really is data. So, you obviously need some data to mash up, and you need data in a format that is easy to use, and you need an API. I'm assuming that most of you are familiar with what APIs are. They just allow you programmatic access to data. So before I start, has anybody used APIs before? Can I just get a show of hands? Okay, all right. How about the Google Data APIs? Has anybody used those before? Okay, a few people, that's great. Okay, so you're probably all familiar with Google's mission, which is to organize and make the world's information and make it useful and universally accessible. So the key ingredients that we're going to be looking at here is obviously information. So this is the kind of data that we expose through our APIs that you can use in your applications, and the idea of how to make it universally accessible. So you've heard about the cloud, in the keynote. And you've heard Brian talk about, open standards, open web. So open is something we really like. We like to be open, and we like to expose data as much as possible to our users. But going beyond that, the APIs really allow you to use this data. So you can not only just read it, you can also write it. So you can use our APIs to write data to our services as well. You can update data, you can delete data, and fully interact with it. So this talk is going to really be broken up into 3 sections. The first section that I'm going to talk about is what kind of data we have available. So you're going to get a sense of what I mean when I say Google Data APIs, what services I'm talking about. The next section is going to go into the actual protocol that we use for our data, which is called the Google Data Protocol. That's going to get a little bit more technical. I'm going to show some XML. I'm going to show you how to work with just the raw protocol. And then in the last section, I'm going to talk about client libraries. And these are the libraries that we've written that make using the protocol much easier. So if you don't like XML, if you don't like working with XML, you just like using Java, you can use the client libraries. And I'll go into those. Okay, so with that, some of the sample applications that we're going to talk about also are, and I want you to try to think of some other stuff as we're going through this that you might be able to do. So we're going to look at how to map photographs from Picasa onto Google Maps using just JavaScript. We're going to look at how you would combine data from Google Contacts with Google Calendar and run this whole thing in App Engine. And we're going to look at how you could combine data from Calendar with YouTube videos. And then we're going to go into how you would upload videos to YouTube. So I hope some of these applications will give you a sense of what's possible. I'm also going to point you in the right direction for finding more sample applications. And at the very end, I'm going to talk about the best ways to get started, which, are just helpful tools and documentation and so on. So the Google Data APIs are a set of APIs. Most are represented here by these icons. I'm going to go through the list in detail. We have about 17 at this point. At Google, we have a whole number of APIs, but not every API is a Google Data API. So Google Data APIs are just ones where the data is represented in the same format. So the data in Calendar would be in the same format as the data in Google Spreadsheets, as the data in YouTube. This just allows you to utilize it very efficiently and not have to rethink how you might translate this data to talk to a different service. These all live in our cloud, so they're reliable and they're scalable. You guys have probably seen or heard a little bit about App Engine. And the same idea is that, you know, this is the same cloud, so it's very scalable, and we support a lot of data. And when I mean that, I mean basically millions and billions. So if you look at some of the stuff that we have, you know, in Picasa Web Albums, there's billions of images in there. We have millions of users. Same for Google Documents. There's tens of millions of documents. Again, millions of users. And this information is relevant, I feel, because it really shows you how easily you could grow your user base. So if you're writing an application, you can tie into Picasa, you can potentially add millions of users to your applications. YouTube is another great example. I always like this stat. So every minute, 13 hours of new videos are uploaded to YouTube. That's just amazing to me. I mean, that means during this presentation, we have about 780 minutes of new video, which would, you know, be like 32 hours to watch that. Now I'm going to go into some of the services in detail. So at this point, I'm going to talk about each API briefly. And if you have specific questions, feel free to stop me and I can give you more details. So the first set of APIs that we have that are part of the Google Data APIs are the Google Apps APIs. So this is for, I'm sure some of you are familiar with Google Apps. This allows you to programmatically manage your Google Apps installation. So you can provision accounts, you can configure emails, you can migrate users. You can also, you know, I've included Google Calendar here because it's a very key component of Google Apps. So you can programmatically access Calendar, create events, all that stuff, and also Google Contacts. Then we have some APIs that are more for managing data. So you're probably familiar with Google Base, our database, Google Documents, Google Spreadsheets. These are also data APIs. Then we have APIs that are for specific Google Web properties. So Blogger, you know, the leading blog platform, has a Google Data API. Book Search is a Google Data API. This has been released fairly recently. Google Notebook, Google Code Search, the Finance Portfolio API, Google Health, which some of you may have heard about. Then we have some multimedia APIs. So I mentioned Picasa Web Albums before. YouTube was the previous talk here. Also has a data API. And then we also have the Google Webmaster Tools API. So I was going to jump into the Google Data Protocol and give you guys a little bit more technical background on how the data is represented. But before I do that, are there any questions on the Google Data APIs? Anything specific that I should answer now before we move on? Okay. Well, we can also save it for the end. So now I'm going to talk about the raw protocol. So just remember that, you know, if you don't like to work with some of the raw protocol and the XML, you can use the client libraries, which I'll go into after that, which explain how to make this stuff a lot easier. But I think it's important to at least get an understanding of how the protocol works, what the building blocks are that make up the Google Data Protocol, because it's going to help you understand what you can do with these APIs. So the building blocks of the Google Data Protocol, first of all, it's XML based. So XML is the base that we use to, the format we use for this data. But it's not just XML, it's actually the Atom syndication format. How many of you are familiar with Atom? Okay, a few people. So the Atom syndication format is really, it's an XML data format. It basically specifies a certain set of elements that are part of an entry, and then it specifies feeds that contain entries. So common use case are, you know, feed readers for news feeds or something like that. Usually that's either an RSS or an Atom format. We've used the Atom syndication format to base the Google Data Protocol on. Another big component of this is HTTP and REST. So our communication layer that we use to send these feeds around is all HTTP based. the real benefit is that, again, it's an open standard, it's widely supported. I think everybody understands how to use HTTP. REST is just, for those that are not familiar with it, it's more of an architectural style for building applications. And it basically means that the resources that you work with are URLs, and you use simple HTTP verbs to manage these resources. I'll go into that in a little bit of a demo so you get a clearer picture of what I mean by that. But the idea is that it's a common format. So if you request some data from one of our API servers and you get a 404, you're going to kind of have an idea of what that means, because 404 is just a common HTTP response when a site's not found. It's not some proprietary error code that you have to remember. It's all pretty straightforward. So the Atom Publishing Protocol is really the protocol that the Google Data Protocol is built on. And the Atom Publishing Protocol really just means the data is encoded in the Atom syndication format, and HTTP is used to send the data. Whoa. So that's the key building block. Of course, we have added some extensions because we wanted to make this stuff even better and add things that are specific to our services. One of the things is obviously that we want the capability to do full search, right? We have a lot of search technology. And the Atom Publishing Protocol doesn't really specify anything about search. So we've added some extensions that can allow you to work with these services in even more powerful ways. So now we're going to look at some XML. So here's what a standard Atom feed looks like. Now I've highlighted the first and the last line in red because that's really the only thing that I'm trying to get across here. So the idea is that you're working with feeds. When you work with our APIs, you're either working with a feed or an entry. So the blue part here is an entry. Now a feed can contain one entry, it can contain many entries. But that's the main thing that you need to remember. You're going to see a bunch of fields inside the entry, like this one that I'm highlighting now, that's a title field. So what you're looking at here is a feed of maybe some blog entries, right? So each entry might have a title. So the thing that I want to get across here is that there are two types of fields. You're going to have fields that you as a user can control. So if you're adding a calendar entry, you would add a title to that. And there are fields that are determined by the server, in this case, the ID. Right? So each entry is going to have an ID that's a unique resource to that entry. A unique link to that resource. When you create a calendar entry, you don't specify the ID, the server specifies it. The same you see with underneath that is an updated timestamp. We may have published timestamps. So the idea is that there's some fields that you control, where you specify information, and there's other fields that the server will add to your entry. Another important concept about the Atom syndication format is this idea of link elements. So link elements can point to all kinds of things. Typically, as in this case, they point to a feed. So you might have, for instance, an entry that is a YouTube video, right? The entry represents the video. That entry may contain a link to a feed that contains all the comments to that video. So it's an idea of how things are linked together, entries to other feeds, comments to related videos, and so on and so forth. I'll go into that a little bit more later, but it's just something good to keep in mind. So now we're going to look at, so you've seen the data format. It's pretty straightforward. Now we're going to look at how you would manipulate this data. So we're going to look at some common HTTP commands that make up RESTful interactions. So the one that you're probably most familiar with is gets. Right? So a get is just what your browser executes when you go to www.google.com. Right? It makes a get to our server, and we send some data back. The typical response code is a 200 OK message. That's a standard HTTP message that gets returned when you've made a request and it's been successfully served. There are some error codes that can happen. Usually these are in the 400 range. I mentioned the 404 before. If you request a URL that doesn't exist, the server is going to send you a 404 not found. There's also a 401, 403. I'll go into these in a little bit. The next thing that you're probably familiar with is a post. Posts are just done when you create data. So if you on a website, you have a form, you fill out your address, you hit submit, your browser is going to make a post to the server and send that data. The typical response code here is a 201, which means it's been created. Again, you have some errors that could happen. And again, these are in the 400 range. 400 range usually means that you did something wrong as a user. So 400 is, I think it means bad input, which basically just means you sent data that the server can't understand. A 409 is a conflict. This is an error that's returned when you create or you try to manipulate some data that we have a different version for. So to give you a very clear example, the Google Contacts API. Right? It's this idea that you have your contacts, and you can access them through an API, and each contact is identified uniquely by their email. Right? So if you were to post me as a contact, you would add my email and post it to the server. It would say, okay, 201 created, I have that entry. If you try to post me again, you would get a 409 in this case, because the server is saying, wait, there's a conflict. This contact already exists. I don't want to add the same person twice. In other situations where this might happen, and I think I have some more information about this later, is tied to the concept of concurrency, which I'll go into in the next section. So the idea is that our servers will also version every entry you send to them. So everything has a certain version ID, and if you update it, you get a new version. So we keep a backlog of all the versions. If you access an old version, you could get a 409 conflict, because the server will say, wait, I have a newer version of this entry, so please use the new one. Puts. A put is something that you may not be as familiar with, because it's not as common of an HTTP verb as gets and posts are. And a put's just used when you update data. So if you get a calendar entry, you change the title, you send it back, you would execute a put. Typically the response is a 200 OK if the put has been successful. And the last one is a delete, and this just means you're deleting an entry. It's pretty straightforward. So that explains some of the common HTTP verbs. These are kind of like the actions that you can execute to work with our data. Here's a whole list of some of the most common response codes. We've seen 200 OK, 201 created. 300 range is a little harder to explain, but you might get a 304 not modified if you're executing a search against a certain feed. So you're saying, give me all the videos that were uploaded today. Right? And the server responds that back to you. Now, if within the same second or a second later, you do that same request again, the server will give you the data, but it'll give you this 304 not modified to let you know that, hey, this feed is the exact same thing you just requested. So in your client applications, you can use that to optimize. We've seen the 400 range, so it's typically a user error. Something's not found. You've sent data that we don't understand. And the 500 range is an internal server error, which means something happened on our end. Now, our hope is that you never see this, because this is a big problem if we have this. But just to keep in mind, if you do see something in the 500 range, something went wrong on our end, and we're probably looking at it. So now we're going to look at what within the Atom Publishing Protocol, how you would work with some entries. I'm only going to look at two basic things, which is to get an entry and to post an entry. The idea is just to show you what the responses are again, what the XML would look like. So if you wanted to get your feed, you would just execute an HTTP GET to my feed. Now this feed, keep in mind, could be anything. Could be calendar entries, blog entries, YouTube videos, whatever. If you did this correctly and that feed, that location actually exists, you would get a 200 OK response, and then you would get the XML that feed consists of. If you wanted to do a post, you would just do a post to a location. So in this case, we're posting to a feed, and you just send some XML in. So in this case, we're creating a blog entry, I think it looks like. So we have an author with a name and an email. We have a title, just entry 1, and we have some content that just says this is my entry. Now, if this went correctly, you would get a 201 created, and as you can see, the XML returned to you contains a couple more things. So you'll notice there's an ID that the server added. There's an updated timestamp. And there's an edit link, right? So I've mentioned links before a little bit briefly. And I've also mentioned versioning. So what you'll notice here is that the ID is example.com/ID/1. That's the resource that refers to this blog post that you just made. The edit link is what you would use to actually modify this blog post. So let's say, I want to change the title or the author or something, right? You'll notice that the link element there is different. You see another one appended to the end. That's our idea of versioning. Now, each service is going to do this a little bit differently, but the concept is the same. It's just that the servers are going to keep incrementing whatever you post to them. Okay, so that concludes the XML part. So if you hate XML, we're done with that. Now we're going to look at the extensions. So now we're going to look at what we have done to build on top of the Atom Publishing Protocol. And these are just things that we thought make sense, these are useful, and I'm going to go into these briefly. The first thing is, we've added more data model specific elements. So you've seen Atom syndication, titles, IDs. It's pretty straightforward for blog entries. But if you want to represent something different, like a contact, you may need a phone number element, right? So we've created separate elements that are for specific fields. The key thing to keep in mind about these is that they all live in a GD namespace. So the first thing there you see is GD. We may have a GD when element for a calendar entry that would represent, the time that the event's taken place and so on. The next big thing we've added is a capability for batch updates. So the Atom Publishing Protocol doesn't really specify how you would work with multiple entries at once. What we've created is we've created a facility so that you can, let's say you have a blog and let's say you have 50 entries and you want to delete 5 of them, you want to update 6 of them, right? If you did a straight Atom Protocol request, you'd have to make requests for each entry, and it would consume a lot of resources to do that. With the batch model that we have in place, you can send us a feed with all the entries in them and specific commands per entry, like I want to delete this one, I want to change this one, and so on. So you can do lots of things at once. The next thing is this idea of optimistic concurrency. I went into that a little bit. The idea of versioning, right? And the 409 error is the thing to keep in mind. If you get a 409, you're typically doing something wrong with versions. The other thing is, that when you have posted an entry, you will always get an edit link back that tells you where you need to post an update to. So we will tell you what version you're talking about. So it's not, there's no guesswork involved. The next part of the extensions are authentication. So obviously, you're going to have some resources that are protected, right? You have private videos, you have a calendar that you're not sharing with people. We've built some mechanisms that allow you to make authenticated requests to these APIs. Authentication is a big topic, and I'm going to point you to some resources that explain exactly the details of how some of this stuff works. The key thing to keep in mind is that we have 2 basic types of authentication. Okay, there's client login, which is just username and password authentication. This is just recommended to be used for desktop applications, if you're writing something for Windows, etc. The idea is that your application will send the username and the password to our server, and we will authenticate you based on that. For web, we have 2 flavors of web authentication that roughly work the same way. There's what we call auth-sub, which is a Google service, and there's OAuth, which is an open authentication standard. Is anybody familiar with OAuth? Okay, a few. They work basically in the same way, and the idea is that they more or less they authorize your site to access a user's account. The real benefit is that you don't have to track their passwords and their authentication information. You don't even have to know their username. The way it works is via redirection. So a user goes on your site, they get a link that says, click here to log into Calendar. Click on that link, go to Calendar, put in their password, they authenticate, And Calendar is then smart enough to send them back to your site with a token that you keep. And your site then uses that token to make requests. So you don't have to know their username and password. You don't have to store it. You don't have to be responsible for it. And we've also added a facility to use the string default. So once you have a token, instead of requesting a feed of user and then some name, you can just use default. And it just refers to the currently authenticated user. So you don't have to even track usernames if you don't want to. OAuth works pretty much the same way as authsub. It's also a kind of a token-based process, but it's even more secure, and it's an open standard that we support. In OAuth, basically the idea is that you register with Google, you create a private key, everything's signed, it's very secure. Another great thing that just happened recently in the OAuth space is that we've created a proxy for iGoogle gadgets. So is anybody familiar with gadgets and iGoogle? Okay, a few people. It basically allows you to write Google data gadgets. So you can run something off of iGoogle that allows you to access to Blogger and make authenticator requests back and forth. And this is pretty powerful because, you know, if you want to distribute your applications, it gives you another place where you could target users. The next thing we've added are alternate output formats. So I mentioned earlier, you know, we were looking at XML, but you know, XML is kind of verbose, and if you don't like it, we also give you two flavors of JSON. So there's regular JSON output, there's JSON in script output. You can also request RSS if you'd rather work with RSS, and we have KML output for specific APIs. I'm going to show you that in the demo I'm doing next. So is people in general familiar with JSON and JavaScript stuff? Okay, I see a few people. All right. And of course, the last thing that I mentioned briefly earlier is support for queries. Right? So we, of course, want you to be able to search the data in our APIs. So we've created a rich set of query parameters that you can use. These are only a very few examples. There's very detailed documentation that I'm going to show you at the end, but the idea is, you know, you can do full text search on the data in our APIs. So here we're querying for the term foo. This next set we're putting a minus sign in front of that, so we're querying for everything that's not foo. And we have also support for some paging with results. So I'm showing you max result equals 25. You can set how many results you want to get back. If you get a feed that, say, has 1,000 entries, you can get 25 at a time, and each set that you get back will contain a link to the next set. So it's very easy for your application to page through feeds. You don't have to remember, you know, what the other URLs are. Okay, so now we're going to look at a simple example application that we've written. This just combines or mashes up the Google Maps API and the Picasa Web Albums API. I put a link up there which shows a version of this. I have my slightly modified version. In essence, they're the same. And the idea to remember is just that what this demos is how simple it is to just get a feed. In this case, I'm looking at my own feed, which is imgdd08.demos. That's my username in Picasa. I have a photo album of pictures I took in Milan, you know, and I'm requesting an alternate output format, which is KML. KML, for those of you that are not familiar with it, is XML, but it's geo-based. So it's an XML format for location. So let me try to run this. This is kind of big. Let's see. Okay, so if you went to the link, you would see this application. It's just called London Travels, and Ryan Boyd, who's also on my team, created this application to map photos in London. So all I did is I modified it to be Milan Travels. So what you see here is just a Google map of Milan, you know, a straightforward map. And as you can see here, I have my feed that I want, right? So I'm talking to Picasa Web Albums. I'm looking at my username, gdd08.demos. I'm looking for the Milan album, and I want KML output. Now all I can do here is click load, and I load pictures that I've taken, and it loads the geo coordinates, plots them on a map, and also loads routing information. so I can figure out, where I've gone from place to place. To show you how this works, we're going to look at some JavaScript real quick here. Okay. Let me see. I think you guys can read that, I hope. So it's a very simple application. We're really just doing basically, I think, 3 things. The first thing is, we're adding a map. So this, for those that are familiar with JavaScript, we're just creating a new map, setting the coordinates to be, the center of Milan, roughly, and just drawing that out on our page. The load album function is what we call when you click on Get My Photos, right? As you can see, all we're doing is we're getting the album KML form element, grabbing the URL that we've specified in there, which is, feeds, Picasa, my album, adding the, requesting KML output, and we're just creating a GeoXML object and plotting the KML onto the map by using the add overlay. This is really all you need to do if you wanted to map Picasa photos to a Google map. Because we have the KML output, it's very simple. And you can see this is like 4 lines of JavaScript. If you wanted to take it further, which is what we've done here, and also add the routing information, we've made a second request to the API. This time, we want to get the JSON out. And the real reason is that, I want to show you some JSON and also how to work with it in an application. I have another slide on the JSON stuff that gets into more of the specifics, but I'm just trying to show you the general concept here. So all we're doing to get the JSON is we wrote a function called getJSON, and we're just taking that URL of that feed and we're cutting off the last parameter. This is kind of a hack, but if you'll remember, the last parameter was alt equals KML because we wanted KML output. We're just cutting that off, and we're calling getJSON. Now inside getJSON, we're just adding another parameter, alt equals JSON in script, and a callback parameter. For those of you that are not familiar with JSON in script, the idea is that with regular JSON output, you can just get your results in JSON, which is a sort of portable data format, a lot less verbose than XML. With JSON in script, you can also specify a callback, which is just the name of a function that gets called when these results are loaded. Right, so you can immediately process this on the client side without the user clicking around or issuing any kind of requests. So what we're doing here is we're just creating this script tag that has this attribute and calls this callback function. And we're just adding that to the page. Whoops. How do I scroll? I guess I'll go down. Okay, and here's our function. Now this is what gets called when the JSON feed has been received. All we're doing in JavaScript is pretty simple. We're creating a waypoints array, and we're going through the feed, looking at each entry, extracting the latitude and longitude of that entry, and creating a glatLong element and adding it to the waypoints feed. And then all we're doing to actually plot the directions is we're creating a directions object, and we're just adding the waypoints, and we're just plotting it. And that's really all you need to do. It's pretty simple. So let me go back. The rest of the stuff we don't need to worry about. I'm going to go back to the presentation and show you what I mean exactly. So again, right, we're just getting a feed, requesting KML output, and then plotting it. If you use Firebug, and I don't know how many of you are familiar with Firebug, but if you do any kind of JavaScript development, it's a really great tool. One of the nice things it can do, and you don't need to read this, but it can show you each request that your site is making. So if you want to really figure out what's going on, I'd recommend using Firebug because you can see the full JSON output. If you were to look into Firebug and see what happens when this request gets issued, you can see that this is what we're getting, right? So first is the function name we specified, which is our callback. And there's a whole lot of information that we don't need to worry about. The key thing is that, here we're starting at entries. So that's our first entry, and then we can issue through that. The way the JSON output encoding works in the Google Data APIs is that we convert elements from XML into name value properties. Attributes become strings, child elements become objects. Any text value is represented with $T as a property. We also concatenate namespaces. So I showed you earlier the extensions, which was the GD phone number, right, for a context entry. We just put a $ in between that. It's something to keep in mind when you're working with these elements. Last thing is XML versioning gets put on the root element. Probably not as important. Here's another little example of just the code of getting a YouTube feed and showing the videos on a website. Again, we're just making a request, just saying the username's foo, to the uploads feed, requesting JSON and script, setting some parameters like format 5 equals we want flash videos, we want 5 results at the very end, and we want to execute show my videos when this stuff is received. Show my videos, again, is just a simple function. You don't need to really remember this stuff, but the key idea, again, is that you can see where the Atom publishing protocol stuff comes through, because we're getting a feed, we're looking at the entries, and we're printing out the titles. It's pretty straightforward. A great tool, if you're interested in the raw protocol, is the OAuth Playground. I'll show you a link to that, but you can go to googlecodesamples.com. I'll show this again later. This is an all JavaScript tool that allows you to make raw requests to our services and authenticate. And it prints out the actual HTTP response, the XML, and everything. So if you need to troubleshoot what you're doing, this is a great way to look at live protocol interaction. Okay, so that was the most technical piece of this presentation. I hope it wasn't too boring, but we've looked at the services before, and we had a little bit of a look at the protocol. The last part I'm going to do now is the client libraries. So what I said earlier is, if you don't like XML, you don't like working with the raw protocol stuff, you can just use the client libraries and they will abstract all this for you. And we have a lot of languages that we've written these in, and if you're familiar with them, it's probably the best way to get started using this stuff. So, like I said before, they abstract the raw protocol. Client libraries are all open source. So we've engineered them at Google, and we maintain them, and they have issue trackers. They're updated. If you find a bug, you can let us know. We'll fix it. And there's a real kind of community effort around these. We've had external contributors, especially for the Python stuff. So if you like to write Python and you want to help with the client libraries, we have a lot of external contributions. And they're also tested fairly well. So the PHP, for instance, has 85% code coverage. So they're professional client libraries that all include unit tests, all include documentation, all include demo applications. It's really the best way to get started. They're available in 6 languages. I'll show you those in a second. And we've also had some contributed client libraries that people have written in languages that they were interested in. There's a great talk, which I can tell you more about in detail, of Jeff Scudder, who's also on our team. He talks about how to create your own client library. So if there's a certain language that we don't support and you really want a client library in that language, this would be a great thing to watch to figure out how to do that. So with that said, here's the languages that we have client libraries for. So Java, JavaScript, .NET, Objective-C, PHP, and Python. So if you use any of these languages, use our client libraries. It's the best way to get started. Now, not all the languages support every service, but we try to make sure they support all the major ones, and we're constantly working to make sure that every service is represented. The Java one probably supports the most services, but the thing that all of them do is support the raw protocol stuff. So they will have classes for authentication, authorization, calculating the content length of your post request, all this stuff that can be complicated to do on your own. Let's see. I'll show you a link to where these pages are. Actually, if you look at all of these since they're open source, they're all hosted on Google Code. So here, for instance, is the .NET client library. You can see we have an issue tracker with issues. We have a wiki page for how to use it. There's downloads. And we have specific tools that we've developed in these client libraries, mostly as demos, so you can figure out what you can do with these. A great example of how powerful some of these are are this document uploader. This was created by somebody on our team, just kind of as a demo project. Didn't take him very long, and uses the .NET Client Library to build a Windows application that allows you to take all your documents and upload them systematically to Google Docs. So you can just drag stuff in here, log in and hit upload, and it'll just do this. We released this in February of this year. It's already gotten, I think, 50,000 downloads. I mean, it's pretty simple to use the client libraries to make pretty powerful applications. So I hope this kind of gives you a sense of what's possible. Now we're going to look at a little bit of code just to show you how you'd use the client library. So before, we've seen some XML being sent around, and it was pretty complicated. To get a feed from YouTube in Python, it's very simple. It's literally, 5 lines of code. So you just import the gdata.youtube.service class, you create a YouTube client, and you request a feed by calling a method on the client. There's no real complicated stuff you have to do. And then you can just iterate through the feed and print out the title of each video in this case. So the idea is that all the XML structure is represented as objects. So if you're familiar with object-oriented programming, it's a lot easier to use. This is great that we have this Python client library because it also works with App Engine. So if you want to write App Engine applications that use the Google Data APIs, it's pretty simple. This just shows you the data structure of an entry. So I know it's a lot of stuff on the screen, but the key to remember is that everything is an object. So here we're just printing out the properties of the first video entry that was returned. You can see there's categories, there's comments, there's content, there's links. There's going to be a list of all kinds of links. And there's a media group object. This is important because for the YouTube Data API, the media group is used to specify the video's metadata. So that's where the title is, where the thumbnails are, the description. And to access it, you would just type entry.media.title and so on. If you wanted to retrieve contacts using Python, again, it's very simple. We would do this on the interpreter. We would just this time import the contact service. And again, we would just instantiate it. And this time we're going to do some authentication. So we're going to log in to contacts. So we're just setting email on the contacts client. We're setting our password, calling a simple function to do our login for us. It does everything on the back end. It'll talk to the server, get the tokens and all that. And then we're just getting a feed of our contacts. And again, we can just print them out. So as you can see, the client libraries work the same way across all the services. So it's very powerful for matching up different services together. So to show you a simple demo application that uses the Python client library and App Engine, here's the, where is that? Okay. Here's the event creator. So this is just a simple application that creates events on Google Calendar and adds your contacts to the events. This is all written in Python. It's all running on App Engine. All I'm going to do is I'm going to sign in here. This is an example of auth authentication, right? Because now I'm directed to the Google login page. I'm going to sign in. Where's my, okay. Okay, and, oh, I didn't put my password. I think I probably have stored an authenticated session in my browser somewhere. Should probably get rid of that. Okay. All right. Let's try this again. Okay, so now I'm signed in. I'm going to just create a new event on my calendar. So I'm actually going to enter the date for the next Google Developer Day in Prague. And as you can see, it's fetched my contacts here already. So it's talked to my contacts and gotten everybody out. This demo account only has 2 friends, but anyway. Okay, we're going to submit it. The event has been created. And again, I talked about the links earlier a little bit. So we have created a couple links here. This would be the alt link and the self link of that exact entry. So if you wanted to access the XML, you would look at the self link, which we'll do in a second. The alt link is important because the alt link always shows an alternate representation of a Google data entry. In this case, it's the actual calendar page. So if I click on it, I get to calendar, and I can see my two contacts that I've invited. And if I went on my calendar, I would see this entry here. Let's look at the self link real quick. If you click on that, we're just going to get some XML. I'm actually going to open that with, let's see, TextMate maybe. Okay, I'll make this a little bigger. And this is just the raw XML. Let's actually format that. Okay. And you can see this is, again, we have an entry here, right? There's an ID that the server assigned to this. There's a published and updated timestamp. Here's the alternate link, right? If you click this link, it actually goes to Google Calendar and opens that event on your calendar. And if you scroll down, you're going to see some custom GD elements, right? So here's the event status, the visibility of it. And here's my contacts that I've added, right? So here's foo@bar.com, and here's the other person. Let's go back to the presentation. So I hope this showed you that it's pretty straightforward to use different services together because they follow the same interaction if you use the client libraries. Here's another pretty interesting mashup application. This is also written in Python. This is also running on Google App Engine. It uses some JavaScript. This basically mashes up Calendar, Google Maps, and YouTube together. And what it is it's called CalViz, and the idea is just that it's a way to visualize your calendar data differently. So if you just get a feed of calendar entries, you would just get a list. So the idea is we're going to create some user interface to represent a calendar. And it's made interactive, so if you actually click on a calendar entry, it's going to open that up and load a YouTube video if it finds a YouTube video that's related. And you can play this right off the page. So you can see the text has been translated. Where's the... Okay, here's a Google Developer Day India. You can see we've loaded a map, and we've also loaded a video together. So all this stuff can be combined pretty easily. Okay. The next thing we can look at is how you would upload videos to YouTube. Now this is slightly bit more complicated because you're authenticating your application, and then you're uploading video. But the idea is that it's still very simple if you use the Python client library. This is a live sample that we have running on appspot.com. I'm going to run it on my local App Engine server. So let's see. I think that's it. Okay, so that's running. So let me go. Where is it? Go to where that is. Okay, so here we have it running. I hope I don't have sign-in problems again because of my cookies or something. Okay, because this is running on Google App Engine and it's running on my local host, you're not actually authenticating to a specific Google username. If you deploy this live, it actually handles this stuff automatically for you. So if you sign in, it'll automatically authenticate. So I'm just going to log in as a random sort of test person. Again, I'm going to use the auth process. So I'm going to request a token, store that token, and make my YouTube requests. So I'm going to sign in to YouTube. Okay, here's my account. And I'm going to, the important part of auth is that there's kind of this authorization process. So the user has control over whether he allows your application access. So I'm going to say, yes, I allow localhost access. I get dumped back into my App Engine application, and it loads my videos for me. Now these are private videos that you wouldn't be able to see on YouTube. but because it's doing an authenticated request, it can fetch these. The way this works in code is, where is that? So is anybody familiar with App Engine and writing App Engine applications? Okay, a few people. So this is, I don't want to get too far into this code because it contains some App Engine specific stuff that may be a little confusing for those that are not familiar with it. I wonder, do I have slides? I don't think so. Well, the key thing to remember here is that we have two scripts that are both written in Python that facilitate upload. The first thing is that we create an upload form, right? So we're just making an HTML form that you can set your video title and your description and so on, and what category you want this to go in. And that, when the user fills that out, when they click submit, we send that form to the YouTube server. And the YouTube server takes the metadata that you have entered into your video and gives you two things back. It gives you a URL that you are going to actually send the file to, and a token that you have to include in your request. The token just associates the metadata that you've just submitted with the file that's coming now. So in your upload code, we are basically, this is really the only thing you need to look at. So we're getting the video title, description, category, and tags that we've entered in the form. We're escaping them because we want to make sure we don't trust user input in case they've put weird characters in there. We're creating a media group. We've seen the media thing a little bit earlier. And we're just setting the video title, description, keywords, and all that stuff. And then we're just creating a video entry, passing in that media group. And then really all we need to do is call get form upload token on the YouTube server, and it'll, on the YouTube client object, and it'll handle all the requests that happen in the background and give us a response. You of course have some error handling in case something went wrong. Then we just parse out the response. We get the post URL and the token, and we create a simple upload form that you click,